मजे से
हेलो, नमस्ते बिटिया, सदैव खुश रहो। आई जेवियन डॉक्टर ब्रजराज सिंह चौहान, एसोसिएट प्रोफेसर, ज्योति विद्यापीठ, वुमेन्स यूनिवर्सिटी जयपुर। प्रोग्राम इज BSc Bed, PCM, 5th Sem. Course is multivariate calculus and vector differentiation, and session of today is numerical problem on double integration. So problem is question 1. Problem is evaluate the integration double integration xy double integration xy upon under root a square minus y square dx dy over the positive quadrant of circle x square plus y square is equal to a square. We have to evaluate this integral over the positive quadrant of the circle x square plus y square is equal to x. This is the integration. Here limit is not given, but the some figure is given here. Figure is circle x square plus y square is equal to a square, and this circle is only for the positive quadrant. So in order to find out the figure or graph of this representation, this is the equation of circle, and equation of this circle is x square plus y square is equal to a square. A is the radius from here to there, and this is the origin, and coordinate of origin is 0, 0, and this is the radius of this circle, and distance of here to the point O to A is A. OA is equal to A. So coordinate of A will be A, 0. We have to find the area only for the positive quadrant. So positive quadrant is this. We have to find the area of only this region, which is enclosed by the x-axis and y-axis. This is the x-axis, and equation of this is y is equal to 0. This is y-axis, and equation of this is x is equal to 0. And this is the boundary, or boundary is nothing but it is x square plus y square is equal to a square. So this is the graphical representation of this circle, and the region covered by the circle and the positive quadrant of this. So in order to get the solution of this problem, first of all we have to find the limit of double integration. So first integration has the limit, this is the limit of x variable. So x lies from here to there. Here to there x is lies. So minimum value of x is 0 and maximum value of x is a. So the limit of x is 0 to a. Now limit of y, the strip which is varies from here to there. So foot of this strip is on y is equal to 0 and the vertex of this strip is y square is equal to a square minus x square or y is equal to under root a square minus x square or only positive. It is because it is we have to find only for the positive quadrant, so we have taken the value only positive. So y foot of y is 0 and the vertex of y is under root a square minus x square. So limit of x is 0 to a and limit of y is 0 to under root a square minus x square and integrand become xy upon under root a square minus y square dx dy. So these are the limit of this question in which we have to find the area of the circle only in positive quadrant. So limit of x is 0 to a and limit of y is 0 to under root a square minus x square. Here we have avoid it, this is the limit in the variable of x. So first of all we have to integrate this function with respect to y. So in order to integrating this function 0 to 8x taking out from the integration and it is y upon under root a square minus y square dy and dx. This function is expressed in this manner. It is because we have to integrate first it only with respect to y 0 to under root a square minus x. Now in order to get the integration we have some substitution and substitute a square minus y square is equal to t. This is the substitution. Differentiate this, we get minus 2y dy is equal to dt. Minus 2y dy is equal to dt. Or y dy is equal to dt upon minus 2. Now we put substitution in this equation. According to substitution, limit also change in this case. So when we put at the place of y 0 and the limit of t will be a square, and whenever we put upper limit a square minus x square at the place of y square, the upper limit will be by squaring root is cancel out, a square minus a square cancel out, then x square. So after substitution all these we get lower limit when we put y is equal to 0, then lower limit is a square, and when we put at the place of y under root a square minus x square, a square and a square is cancel out, we have remaining function is x square, and y dy is equal to dt upon minus 2, dt upon minus 2. So minus 2 is taken out from integration, it is constant, and under root a square minus y square is under root t and dx. Now after substitution this function is reduced into this form. It is because we have, whenever we have some substitution, limit is changed according to the new variable. So new variable is t and limit of t is a square to x square. Again now minus 1 by 2 taking as common 0 to a x and integrating this t to the power 1 by 2, and in numerator t has the power minus 1 by 2. So after integration, t to the power minus 1 by 2 plus 1 upon again minus 1 by 2 plus 1, and after integrating, this lower limit is a square and upper limit is x square dx. Again minus 1 by 2 0 to a x and t to the power 1 by 2 and upon 1 minus 1 by 2 again 1 by 2 and dx. So 1 by 2 and 1 by 2 is cancelled out, and consequently the integration limit 0 to a x t to the power 1 by 2, t is nothing but it is under root a square minus y square dx. T to the power 1 by 2. Sorry, here we have to put the lower limit and upper limit at the place of here a square and this is x square. Again minus 0 to a x and putting the upper limit x square at the place of t, it become x minus at the t to the power 1 by 2 we have put a square, then it become a. Now dx. This is the final function. So again minus 0 to a x square minus ax dx. Now integrating it with respect of x minus, it gives x cube upon 3 minus a x square upon 2 limit 0 to a. Again putting the upper limit at the place of x, it gives a cube upon 3 minus a cube upon 2 minus, if we substitute upper limit at the place of this x or this x, all term will vanish. So here the final answer a cube upon 3 minus a cube upon 2, or after taking LCM 2a cube minus 3a cube. 3 2 is 6, 2 is multiplied here, 2 3 is 6, 3 is multiplying here, and we get minus a cube upon 6. So minus is cancelled out and a cube upon 6. This is the final answer of this integration which is in front of you. Again recap this question. Evaluate xy upon under root a square minus y square dx dy over the positive quadrant of circle x square plus y square is equal to a square. So we draw the circle x square plus y square is equal to a square. This is the origin, and this circle intersect the x axis at the point a0. It is because here a is the radius of this circle. So we have to find area only for positive quadrant, and positive quadrant is this. Here x varies from 0 to a and y varies from here to there. Here y is 0 and in at this vertex of this script value of y is equal to root a square minus x square. So putting these value in the limit is 0 to a, x 0 to under root a square minus x square, y upon under root a square minus y square dy dx. This function can be expressed in this manner. It is because first of all we have to integrate only with respect to y, then it integrate with respect to x. So in order to integrating with respect to y, we have to substitute something, that is a square minus y square is equal to t. And putting the a square minus y square is t in such a manner, and it is root of t, and differentiate it, it gives minus 2y dy is equal to dt, then y dy is equal to dt upon minus 2. According to this substitution, limit is changed. So putting the limit, lower limit 0 at the place of y, the limit of t will be a square. When we put upper limit at the place of y, then it gives a square minus x square, and a square or a square is cancelled out, and x square is remaining. So limit will be x square, and substituting these values simultaneously with the limit dt upon root t dt. So then integration of dt upon root t to the power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. Minus here remaining term is 1 by 2, and 1 by 2 is in denominator, so both is cancel out, and t to the power 1 by 2, lower limit a square and upper limit x square. So first of all we have to replace t by the upper limit x square. So x square putting at the place of t, it gives x. When a square is substitute at the place of t, then it gives only a. So the remaining function is minus 0 to a x minus a dx. X is multiplying inside the bracket, and it gives x square minus ax. Again integrating it with respect of x, it gives x cube upon 3 minus ax square upon 2, lower limit is 0, upper limit is 8. So putting the upper limit at the place of x, it gives a cube upon 3 minus a square upon 2, and it is multiplied with a, it gives a cube upon 2. And whenever we put the lower limit at the place of x, both terms will vanish and gives the 0. Now finally we have the a cube upon 3 minus a cube upon 2. So solve these two terms taking the LCM, and it gives the 2a cube minus 3a cube, and difference is a cube minus a cube upon 6. 1 minus is present already here, so minus into minus is plus, and final answer is a cube upon 6. So this is the answer of this integration. Next, I hope you all are satisfied with this solution. Next problem is I have another problem which we have to solve here. Our problem is the evaluate the integral. Evaluate the integral of r under root 4x square minus y square dx dy when the region of integration r, region of integration region of integration r is triangle triangle bounded by triangle bounded by x is y is equal to 0, y is equal to x, and x is equal to 1. This is the numerical problem of double integration. Here we have given a region which is enclosed by the axis y is equal to 0 and line y is equal to x and x is equal to 1. So with the help of this bounded curve, we have to find the limit of this integration. So this is the two-dimension space, two-dimension. This is origin. Now y is equal to 0. This is the y is equal to 0. The equation of x-axis is y is equal to 0. X is equal to 1. This is x is equal to 1. Now we have to draw the line y is equal to x. This line is y is equal to x. This line is y is equal to x. Now we have three lines, y is equal to 0, y is equal to x, and x is equal to 1. So area bounded by these lines, we have to find out the value of this integration. So in this case, x lies from 0 to 1. This is 1, 0. The coordinate of this point is 1, 0. So x is lies from 0 to 1. Limit of x will be 0 to 1. Next, this is the strip which is moved from here to there. Foot of this strip is y is equal to 0. Foot of this strip on y is equal to 0. So y is equal to 0 is the lower limit and upper limit is y is equal to x. So in this case, x varies from 0 to 1 and y varies from here to there. In this strip, foot is the y, foot is on the y is equal to 0 and vertex is on the y is equal to x. So this strip lies between 0 to x. So limit of y is equal to 0 to x. This 4x square minus y square dx dy. Now we have to integrate this integrand. So we have a formula of integration form: a square minus x square dx is equal to 1 by 2 x under root a square minus x square plus a square sine inverse x upon a. This is the formula. We have to apply this form in order to find out the integration of this. Both are the same form is here. In this case, when we compare this integrand with this formula, a is equal to a will be 2x. A will be 2x and x is equal to y. When we compare this integrand by this formula, so a will be 2x and x will be y. According to this formula, we have to integrate this integrand with respect to y. It is because this is the limit in the form of variable x. So this is the limit of x. First of all, we have to integrate this function with respect to y, and right is 0 to 1, bracket start, 0 to x under root 2x square minus y square dy again dx. This function can be expressed in this manner. It is because the form of integral is this. According to this formula, we have to write the integration of this, that is first of all x 1 by 2 and x is nothing, x is equal to the y. So we have put y under root under root 4x square minus y square plus a square. At the place of a square, it is 4x square. Sine inverse at the place of x, y, and at the place of a, 2x. Lower limit is 0 and upper limit is x. By this form, we convert this function into this form and get 1 by 2 y under root 4x square minus y square plus 4x square sine inverse y upon 2x, lower limit 0 and upper limit x. Now we replace y, first we replace y with this x, again minus, then we replace y by the 0, then we got 1 by 2. At the place of y, we substitute x. So x under root 4x square minus x square. It is because y is replaced by the x, plus 4x square sine inverse, at the place of y we have put x and upon 2x. This is first expression. Minus, we put the 0 at the place of y. Whenever 0 is put at this place, this term will vanish. Again 0 put at this place, sine inverse 0, sine inverse 0 is again 0. So both terms will vanish and gives 0. Now we have the function 1 by 2, 0 to 1, x under root 3x square plus 4x square sine inverse 1 by 2. Sine inverse 1 by 2. Sine inverse 1 by 2 is pi by 6. It is because sine 30 is equal to 1 by 2. So sine inverse 1 by 2 is equal to pi by 6. Again solving 0 to 1, 3 is in under root and x is out of this, so x square root 3 plus 4x square and sine inverse 1 by 2 is pi by 6. We have to integrate this function with respect to x. Again we can take x square common, so taking x square common, it will explain as x square in the bracket root 3 plus 4 by 6, or 4 by 6 is nothing but 2 by 3, and pi also. 4x square taking common, and here remaining term is root 3, here 2 by 3 and pi also. So it is dx. Again 1 by 2, and this is the constant term, so taking out of the integration root 3 plus 2 pi by 3 is taken out of this integration, and x square dx is remaining, and 0 to 1 is the limit of this integration, 0 to 1. This can be written as root 3 by 2 plus pi by 3. This is common, and integration of this is x cube upon 3, lower limit 0 and upper limit 1. So root 3 by 2 plus pi by 3 in one bracket, and putting the value of 1 at the place of this gives 1 by 3. So the answer of this question is root 3 by 2 pi by 3 into 1 by 3. It is because whenever we put the 0 at the place of x cube, term will vanish. So this is the solution of this numerical question. Question is in front of you. Double integration, region is given here, and integrand also given here. Our region is bounded by these three lines, that is y is equal to 0, y is equal to x, and x is equal to 1. These three lines, area is enclosed by these. Y is equal to 0 is this line, x is equal to 1 is this, and y is equal to 1, y is equal to x is this line. So we have to find the region of this area enclosed by these three lines. In order to getting the limit of x, x varies from 0 to 1. Minimum of x is 0 and maximum is 1. Now taking a strip parallel to y-axis, and foot of strip is on y is equal to 0 and vertex of strip is on y is equal to x. So limit of y is equal to 0 to x, putting the limit in. This is the integrand, or this is a particular form of integration. That formula is written in here, root a square minus x square dx is this. So in parallel of this, we reduce this integrand in this form and putting the lower limit and upper limit. So according to this formula, the function will 1 upon 2 y root 4x square minus y square plus 4x square sin inverse y upon 2x, lower limit 0 to upper limit x. Now we replace y by this upper limit x. So when we replace y by the upper limit, it gives this function. When we replace the y by the lower limit, all these term will vanish, ये 0 हो जाएंगे. तो जैसे इसकी वैल्यू पुट करेंगे ये 0 हो जाएंगे. Now we have to integrate this function is with respect to x. Here dx is out of now 1 by 2 x 4x square minus x square 3x square x square taking common under the taking out from root, it gives x square outside the root, and in the root there is only root 3. So 4x square sin inverse x and x is cancel out, it gives sin inverse 1 by 2. We are knowing well sin inverse 1 by 2 is equal to pi by 6. So we put these with the value of sin inverse 1 by 2 pi by 6. So now we get the function 1 by 2 0 to 1 x square root 3 plus 4x square pi by 6. Here we can cancel out it 2 2 ja and 2 3 ja. It gives the 3 by root 3 by 2 plus 2 pi by 3 by 2. Again divided by 2, it gives root 3 by 2, and 2 is cancelled out by the 2 and it gives pi by 3. And the integrand is only x square, so integrate it with respect to x, we get x cube upon 3, lower limit 0 and upper limit 1. Whenever we put the upper limit, it gives 1 by 3, and we put lower limit, it gives only 0. So after multiplying this we get root 3 by 2 plus 5 by 3 into 1 by 3. I hope you all are satisfied with this solution of this numerical problem, and if you have any query, please mention in comment box. I will resolve it very soon and meet in the next lecture. Thank you very much.